My name is Ashish Jauhri. I'm a design director with a company called DSP Design Associates. We are a 240 professional company with 5 studios across India in Mumbai, Bangalore, Pune, Hyderabad, and Delhi. We have a global design cell, and as per the latest World Architecture Ranking 2017, we are 66 in the world. Typically, we offer master planning, architecture, education, and interiors as a service. Couple of projects I'll take you through before I go through so that you understand what DSP does across the country. This is a 100-acre master plan that we have just won as a competition in Bangalore. It's about 16 million square feet, about 5.5 million of commercial, 7.5 million of residential. There is a F&B sports stadia. This is another project in Bangalore which was completed about 10 years ago. We got an award from the American Concrete Association for this project. This was for Oracle Financial Services. This is another interesting project in Bangalore. This is for Huawei Technologies, electronics manufacturing company, 1.5 million square feet. This is a competition we have recently won. The government of India intends to make a School of Economics on the lines of London School of Economics in Bangalore. So we have won this competition and it's about to get construction in the next few months. This is another competition entry which we won in Bangalore again. It is a convention center with 2,000 seater auditorium facility. This is a commercial building in Pune. Another commercial building in Mumbai. It's about 4.5 million square feet on a 36-acre campus. This is one of the very interesting projects that we are doing right now in Mumbai, in Worli. This was originally designed by a London-based architect called Foster & Partners. We have taken over this project and we are at the finishing end right now. The first 2 towers are already up about 300 meters tall. The third one is midway up in the air. This is another residential high-rise project in Mumbai, another one in Mumbai. So that brings me to my talk. When we were invited for this talk, I was just thinking, what would be the best topic? And with the advancement of facade technologies and the steel being used more and more in India, I thought perhaps the juxtaposition of how facade and steel structure are coming together would be the apt topic for today's thing. Before I start with that topic, typically, what is the driving force, that makes us move forward and go from one to another benchmark, and when we achieve something and then we want to move forward. It is usually the fear of being obsolete. All architects, designers, everybody face this kind of a challenge in their lives, So we intend to innovate. And I thought the best example, which actually 130 years ago was undertaken, was the Eiffel Tower. And Mr. Gustave Eiffel himself had said on the integration of structure and cladding systems at that time, saying, because we are engineers, is one to believe we give no thought to beauty in our decisions, or that we do not seek to create elegance as well as solidity and durability. He also went about saying, it is not true that the very condition that gives strength also conform to the hidden rules of harmony. So I start my talk with this topic, and I want to show you some more examples of projects where facade and structure are sort of coming together primarily. So this is the Apple showroom where literally, whether it is facade or structure, it is difficult to say, in New York. This is another building in London called Swiss Re building, where again the facade becomes part of the structure of the whole building by itself, by Foster's. This is a very interesting building in Abu Dhabi, which was given the furthest leaning man-made tower, after the Tower of Pisa, of course. Yeah. So Mr. Vitruvius, a long time ago, had laid 3 basic principles of building design for any architect to take upon. They were firmitas, which means strength, utilitas, which means the functionality of the building, and venustas, which is to do with the aesthetics of the building. All this while, all the buildings have been using this as the main principles when buildings are being designed. Over the last few decades, a 4th virtue is being looked after into, which is called mobilitas, primarily. It is coming from the aspect, in this particular case, from the dynamic character of the facades, the adaptiveness of the facade, the responsiveness of the facade, and so to say, the intelligence, the facade being more intelligent. So I thought this example is the perfect example to show. This was by Jean Nouvel in Paris about almost 30 years ago, I would say. The most interesting part about this building was that it was a plain glass facade, but the inside of it, because the amount of heat and sun that was coming in needs to be regulated, so Mr. Jean designed apertures inside the building which would have sensors which would allow the amount of light and heat that enters into the building. And these sensors are actually like a camera aperture, and they open and close on the basis of the sensor. Unfortunately, the idea was great, but at that time the sensors were not really working well. But it is still a thought which has made a lot of people to think beyond this point primarily. I went to this building, it is fantastic. I thought they could now have the technology, have the best of the sensors, best of the technology, they could retrofit this building and make it work really. So we move forward. Another example that I thought would be very useful here, where the facade is moving, the steel is being used. It's a Milwaukee Art Museum by a famous architect, engineer, Santiago Calatrava. The fins close like the bird's wings primarily over here, allowing enough light and ventilation when it is required, otherwise closing it off when it is not required. Because the sensors was not working at that time, when Jean Nouvel did that building, recently this building has come up in Abu Dhabi, which is called the Al Bahar Towers in Abu Dhabi. And here, the sensors are able to understand where the sun is coming, when do these facades need to open and close primarily. So I thought this is quite a good example of what we are talking about, integration of facade and structure put together. This is also a very interesting project. It's a John Hancock Center in Chicago. It's on the 94th floor. It is just for fun, but it is a great piece of architecture, because what happens, this whole window, a press of a button with using hydraulics comes out, and you get scared. But it's for the fun that people go to this building. It's a very well-known building in Chicago. Right? Besides that aspect, because a lot of emphasis is happening on energy as well, we did this building, is my ex-firm in Dublin, where the BIPV was taken as part of the solar shading, and it was sandwiched into 2 glass pieces. And these little boxes that you see on the top are the cells which are creating energy, and this was enough to take care of the common areas to be using solar energy primarily. However, a lot of research has happened. And recently, this solar project in RMIT in Melbourne has come up, whereby the photovoltaic cells are being used. In one way, this building is actually a milestone by itself. I'll tell you why. They have designed the building thinking that the research in solar energy which is happening across the world is changing so rapidly and so fast that time will come that these kind of BIPV will become obsolete. So they designed this in small bits and pieces on top of each other, and you could replace these as and when the technology becomes better, which means that in 20 years' time, this building will still be the best technologically building, because it is using the BIPV, and it is based on the same frame structure it was designed upon primarily. So when we are designing building, there are too many components, too many people, too many aspects, facade, structure. Eventually, it is the occupants, it is the natural light and quality, the glare aspect, the heat coming into the building, the connect to the outside environment. For maintenance guys, replacing of the elements, how to clean the facades. For owners, it is always about how to minimize the running cost of artificial lighting, bring in as much as natural lighting as possible. And the last but not the least, the onlookers, who always have an opinion about any building that you make anywhere, because they become part of the public foray primarily. So I'll start with this case study. I'll tell you a little bit of background about the project that I've chosen. It was a competition that Mr. Narayan Murthy from Infosys had invited us to come and compete. They have a campus of about 63 acres in Bangalore, and they wanted to have 15,000 employees in a 5-acre plot, which means we had no other choice but to go tall. So we had to go 100 meters tall, 25 floors approximately. So this is what they came up with. They said we need about 15,000 employees location. We understood the car park requirement about less than 3,000, which is quite a high one at that time. We also realized that we have to provide spaces which are green, because everybody cannot come to the ground. We have to bring these spaces up in the air as well. So that became part of the inherent theme or the design brief. However, it did not stop over there. They wanted a building which is energy conscious. They wanted a building which is futuristic. They wanted a building which is iconic in nature, because Infosys is coming up with this so many campuses across the world. They wanted to show their iconicity, their new global location position, from their headquarters, which we started actually. And then of course it has to be green and innovative in nature. So all these put together, we had to come up with the building, which conforms to these, if not push the boundary a little more further, which is what Mr. Murthy is always pushing everybody around in his own company and otherwise. So as a thought starter, we realized that the existing campus is a very horizontal campus. We had to bring this same environment of green trees, etc., up into the vertical environment primarily, which means that bringing all these gardens, how to bring them up in the air, that was one of the challenges. Secondly, when you build buildings, which are of a certain height, it impresses upon the surroundings. So we have to make sure that the surroundings are not compromised upon. So the buildings that we design needs to be responsive in nature. So we came up with these ideas about putting vertical campuses, connecting floors between each other, creating holes within the thing, finding an environment where greenery can be brought into. A lot of research was going on. We took almost 6 months for designing this particular campus. So I'll quickly take you through. I was talking about this site, which is 63 acres, and our site was 5 acres, which is over here. This is if you know Bangalore, this is the biggest, tallest, longest bridge that they have. The Electronic City flyover, it is called, 10 kilometers long. And this building, this whole campus is visible on the right-hand side in phase 1 of Electronic City. So we realized that they had all sorts of shapes and forms. No disrespect to whoever designed earlier, but there was no harmony in the campus. So we thought perhaps because this is going tall, it would be the defining moment for the campus to come up with a building which can actually tell the language that needs to be given, not just in terms of visual, but in terms of energy efficiency, in terms of any other aspect that somebody would want to relate to a company primarily. So when we saw the site, we realized there is a little bit of green cover, and as a purist thought of an architect, you don't want to touch any of the trees. So we came up with this idea that we will just squeeze our building in wherever there is land available and not touch the trees at all. However, when we did the analysis, we realized that natural light was not coming inside the building, and this scheme would actually mean a lot of energy being used. So we realized that this is not the right way. So we worked upon options. We worked upon, I don't know, at least 10 options, out of which we shortlisted about 6 of them. And we realized that perhaps a scheme which is more open, and still going tall would be the right one to do. So the design evolution happened like that. If you were to take up the site and look at all the parameters around it, you get a building which is something like this. But if you build a 60,000 square feet floor plate with a core in the middle, you realize that a lot of light will not come inside the building. Typically, light reaches about one grid of about 11 meters, 35 feet, a little bit more than that, not more than that. So the obvious choice was to divide this building into 2 blocks to be able to get enough natural light inside the building. I'll take you through what analysis we did a little later. And then the evolution of the building started. We wanted to bring a lot of greenery into the building. So we thought perhaps the gardens can be brought into the building as they go up and staggered a little bit, and they can be connected at floors. So if you want to go to a green space, you literally have to walk 1 floor up or 1 floor down from your office space instead of coming all the way 22 floors down primarily. So the form started with 2 buildings. We thought perhaps we should make them talk to each other in some manner or the other, some sort of a converging volume coming in together. And then the central space binding together this whole thing, the concept of yin and yang came into picture. We softened the edges to allow the wind to pass through, easily, smoothly primarily, and we connected the buildings together. And an expression came where as the buildings go up, we twisted the buildings a little bit. Primarily, it was done for 2 things. One is the iconicity and the character of the building, and second is the self-shading component, whereby by twisting the building, you can have the shape of the building shade a certain amount of facade of the building primarily. Because glass is an obvious choice, so you have to find ways how to deal with sun and the shading aspect of it. So that's the building came up with. Then came the structural aspect of the building. We did a small model to understand how this whole shape and etc. would work out. So this was a time when we started to get a little more inspired. We wanted something more extraordinary, both in terms of planning as well as the structure. And so we got some inspiration from nature. People call it biomimetics, which is mimicking the nature. Actually, it is just a fad. Architects have always been using nature as an inspiration. It is just selling the same design again using a new technology, terminology primarily. But the best part about using a leaf structure as the structural component of the facade of the whole building was to be able to find a diagrid which would span about 3 floors, and it would divide the whole facade in such a manner that you have windows to be filled up. These windows are not 1 story tall, these are 3 story tall windows primarily. So we thought perhaps we would do this. And then we called up Mr. Abhay Ghate from Optimal. He's a very passionate structural engineer, I love him. And he came up with this idea when I told him, sir, I need a building, but I really don't want to have any columns inside. So he did all his analysis, ETAB model, night 11 o'clock, he called me, Ashish, I think I've solved your problem. And he came up with this structure whereby there was not a single column inside the building. He designed the structure in concrete, which is the core, and the slab in concrete. But the diagrid, he said, we will do it in steel, and it will go around the building, and it will come as a crosser structure. And he did an ETAB model, and it was working very well. Thankfully, Bangalore doesn't fall in the earthquake zone for that matter. So finally, we came up with this structure. It was a 3-floor diagrid structure, which was steel column bracing at every interval on all the floors primarily, right? Then it is time, so the structure is resolved. We have a column-free space. Imagine the amount of space that we have used and saved. We did not have a single column. It is only the core and the floor plate by itself. Then it was a time to understand how does the furniture fit into the floor plate, how much natural light will come inside the building. So we did some ecotech analysis as well. We did a fit out of the furniture. We looked into all the months, September, June, December, and we realized that the amount of natural light that is coming is about more than 80% of the floor plate was getting 300 lux or more throughout the year, which means the reliance on the artificial lighting is minimal on this building primarily. So energy consumption obviously will come down. Then once you allow the sun to come in, you have to shade as well. So we have to find a strategy to shade. Then we started to look into the energy aspect of the building. So we found a couple of futuristic technology, which I'll just touch base quickly for you. One is called the TLSC, which is the Transparent Luminescent Solar Concentrator. So this is an interesting technology because you don't need to bring in BIPV to put it in your windows. You can use an existing glass and put this film on top of it. And there is a solar cells which are on the periphery of this thing, which are going to take all this energy that is being absorbed by this membrane and pushed into the periphery of the window. So you can have your existing window work like a BIPV primarily. That's the great thing about this technology. But we didn't stop there. One of my colleagues, he's very enthusiastic about finding new technologies and how to integrate them into building. And I want to just take you a little to this video, right? You bear with me for a second. Yeah, this is a research by a student, by the way.
And my project is called Silk Leaf, and I'm showing it here in Royal College of Arts at the final year show. Silk leaf is the first man-made biological leaf, and with this I mean that it's a material that uses photosynthesis to absorb CO2 and transform this using light into oxygen, thanks to a material that is extracted directly from the fibers of silk. And this material has an amazing property of stabilizing organelles or organic molecules inside its own matrix. I extracted chloroplasts from plant cells and I placed them inside this silk material, silk protein. And as an outcome, I had the first photosynthetic material that was working and breathing as a leaf does. It's very light, low energy consuming. It's completely biological, and my idea, in fact, was to use the natural efficiency into the man-made environment. First of all, I was imagining it as a free surface that you could manage even for interior design or space separations. I also created some lighting out of this material, like using the light for us to illuminate the house, but at the same time using that light to create oxygen for us. But at the same time could be used for outdoor applications, so facades, embedded inside ventilation systems. You can absorb air from outside and pass it through these biological filters and then bring inside an oxygenated air. Oxygen is very good for human well-being. As you know, oxygen improves the longevity of human life, improves the focus of us, and also health. So many also other details around this. Silk leaf could be also used for space exploration or space architecture, simply because, as you may know, plants doesn't grow in zero gravity. NASA is researching, trying to find different ways to produce oxygen for long space journeys, or also to let human living into space. And so this could be really one of the first device material that could allow us to then go and explore the space.
Right. So we found this such an interesting material that you are up in the air, 20th floor, and your window is acting as your tree, which was in your garden. You know, what kind of technology? I mean, if we get something like this, the whole industry is going to change. Right. So we realized that we have to put these gardens across anyway, because unless you are close to a plant or a tree, you don't feel that you are close to nature. So we had to take these trees up in the terraces across the building, but we thought perhaps the glass, which is going to go around the building, can have that technology inside, you know, as we go in the future. So we designed these two towers with these terraces which are connected into each other, you know, having a space for somebody to walk in one floor up or one floor down to be able to enjoy the nature instead of going all the way down 22 floors, basically, right? Then we connected the buildings, you know, with the bridges as well, so allow for people not to go down and then go up again. You know, you can walk down few floors, go across. So that's where all these forced movement come into picture, where people are interacting with each other within the same environment, same company. These are some reference images we thought perhaps for the landscape that we would do across the towers within the central space, you know, how the bridge would look like. But the most interesting part was about how to shade the glass and how to make sure that you do a glass building, but you don't bring the curtains down. You know, you have to make buildings where the sun is utilized to the best, but not compromising the comfort of people who are inside. So we studied, as the model goes up, you know, we studied how the sun is affecting on various surfaces. We did some analysis in terms of our solar shading to various surfaces. We also looked into how the sun, you know, how the whole surface and where exactly sun would come and where would we require to shade it primarily. Sorry. Yeah, that's where it is. So we realized we were able to map each and every point onto the facade of the building, and it was trying to find a solution which is not very cost effective, you know, which is very cost effective, as well as it is apt to the face of each and every point onto the facade. So we came up with something like this. You must be wondering, what are these dots standing for, right? I'll tell you, these are nothing but small sun shading, but sun shading that happens aptly at where it is required to the extent where it is required. I'll get you a little bit of detail into it. This is a heat model which you see at the bottom, right? So what we did is, we realized that we have to fill these rhombuses which you saw in the diagram primarily, and we designed 6 type of various panels which has sun shades which would extend about 150 to almost 900 mm from the face of the facade. It will come in and out, and we standardize them so that we can have a cost-effective solution to be able to do that. And then we did a little model to understand how would it look between these 3 floors of diagrid, and then this model came up, something like that. And finally, we had this study where we could understand how much sun is being blocked at various levels on the facade. And then the computer helped us to understand where these panels will go. So it was a very technically challenging, but the technology itself gave the answer, where to put what kind of panels primarily. So this whole facade, which is opened up from the building, has been put in such a manner that wherever you need, what kind of shading is put across all the floors, you know, distributed across primarily. So finally, we found a building which was technologically advanced, iconic in nature. I want to show you a little video of that.
The new facility for 15,000 workforce is envisaged to be a symbol by creating a new city landmark. And we believe that the architecture of this new headquarters should reflect the company's rising international influence. An avant-garde structural expressionism, usually implicit in architecture, is proposed by using a dia grid to integrate facade and structure design. This helps to provide floor and facade efficiency and panoramic views. The parametric facade design facilitates glare-free work environment. The main arrival experience is envisaged to be at the landscaped podium and allows employees to reach via a majestic flight of steps. These also provide for a community space for various groups to interact, besides promoting walking. The aim here is to provide a culture change that would encourage more interaction among Infosys members. The solution demands the ethos of a vertical campus. We did a lot of research about campuses and we have applied that to these towers. This is achieved by connecting bridges between the buildings, providing indoor garden atria, fully integrating natural elements of exterior with interior workspace. The twisted form provides self-shading and hence shields itself from the stronger solar gain, decreasing the heating effect of direct sunlight and increasing comfort levels for occupants. This facility will surely be a visual experience to the onlookers, making it both iconic and futuristic, thereby speaking itself about the leading position of Infosys in the 21st century.
That's it. Thank you very much for the day.